So I'm going to start with this little section of the graph where I have the line and everything else and then the proportion set up. So I want you to label this. This is the solving section. So if we're solving some sort of equation or inequality, this is what's going to help us. So the first part over here is with the everything else in the line through the middle is designed with help us solving equations or inequalities, whether it's a less than, greater than, less than or equal to, or greater than or equal to. So for example, you do not need to write this, but for example, if I had 2x plus 3 equals 15, and I need to solve this, the way we would solve this is we would label the left side as x because that's what I'm solving for, and the right side as everything else. Notice that up here it has the right side labeled as everything else, so that way we can figure out what needs to go over there. So if everything else means that if it doesn't have an x, it needs to be on the right side. So I need to get rid of this plus 3. To get rid of this plus 3, I'm going to do the opposite, which is to minus 3 from both sides. And I end up with 2x equals 12. And then to get x by itself, I'm going to divide both sides by 2. So divide by 2, and I get x equals 6. So this is a sample problem. Again, you do not need to write this down. So as far as the proportion goes over here, this is just to help me remember that if I solve something, for example, again, you don't need to write this necessarily, but if I had a proportion of x over 6 equals 6 over 9, to solve this, what the butterfly method over here tells me is that I need to multiply the bottom times the top and the bottom times the opposite top. So, and that's how I solve this. So I would end up with 9x equals 36, and then to get x completely by itself, I'd divide both sides by 9, and I would end up with an answer of x equals 4. Again, that was just an example problem to show you what you would do. But regardless, this entire section over here in this part of the box is designed to help you guys with solving. This section where you have two really weird things like an elbow and some trees is to help you with your quadratics. Remember, your quadratics are anything with an x squared in it. All of the graphs are a parabola, which is what this part is to help you remember. It's a parabola, and we use the u because there is a u in quadratics. So these are our quadratics. I'm just going to put quads there because I'm running out of space. So I'm going to put quads there. So this graph, the U-shaped graph, first of all, it has a vertex, and that's what our elbow is for. The elbow is to help us remember that it's our vertex is where the graph bends, so that would be this point on my quadratic. And then it would also be this point. If I look at this graph, that's my vertex. And then the tree over here is intended to help you remember that these points on the x-axis are called our roots. These points are called our roots, and that's what that picture is designed to help you remember. The next thing we're going to look at is all the different words and all the boxes that we have, and so we're going to start with HIO. HIO helps us remember that our horizontal transformations are inside the parentheses, and they are the opposite of what we think they should be. So when we start talking about our transformations, for example, you don't have to write this, but if I have f of x plus 2, we can remember that because this 2 is inside the parentheses, then it's the opposite of what we think. So instead of plus, we're going to be doing something with minus, and it's horizontal, so that tells us either it's going to actually move to the left 2 units. That's what this plus 2 means. The next part is PEMDAS. This is to help us remember our order of operations. So this stands for our parentheses. So the first thing we do when we're working on a problem is work out what's inside the parentheses. Then E stands for our exponent, so that's the second thing we do. Next, we multiply or divide. And lastly, we add and subtract. So the PEMDAS is designed to help us remember when we solve problems, this is the order we need to go. We do parentheses, exponents, multiplication, division, add, and subtract. This next part is for our exponent rules. So imagine if I had x to the second. That's what these boxes are there to help you remember your exponent rules. If these are your exponent rules. So the exponent rules say if I have exponents to exponents, then I need to multiply my exponents together. And then if I am multiplying, so I'm working up the table. If I'm multiplying, I need to add my exponents together. And then if I'm adding, I do absolutely nothing to my exponents. And I can also add in here that if I am multiplying or dividing, and then with my adding, I can also add in that I can subtract. So dividing leads to subtraction. So that's what the word name is designed to help us with. To the right of that, this is a reminder that if you have something like x plus 3 times x minus 4, then we need to fill in these boxes on the side, and then we can multiply to multiply our polynomial together. So we could go ahead and do x times x, which would give us x squared. Negative 4 times x would give us negative 4x. X times 3 would give us 3x. And negative 4 times 3 would give us negative 12. So this is to remind us how to use the box method for multiplying polynomials. We have the word Tebow. Tebow stands for top, in, bottom, out. It stands for top, in, bottom, out. And that is when we're talking about rational exponents. So if I have something like x to the 3 over 2, then when I rewrite this as a square root or using a radical symbol, my x is still going to go inside because that's where it needs to go. My bottom number is going to go outside, so it's going to go here on the outside of the radical. And then my top number is going to go inside. So the 3 is going to go inside the radical symbol. So that is how we remember Tebow. That's what Tebow stands for, is how we rewrite rational exponents. This tic-tac-toe board has helped us remember our multiplication rules. So our multiplication sign rules. Let's be a little more specific there. It's our multiplication sign rules. So if you have, say you have two negative numbers, well, if you multiply a negative times a negative, you're going to get a positive. If you had one of each, a negative times a positive is going to give you a negative. Or a positive times a negative is going to give you a negative. If you read the chart diagonally, a positive times a positive is going to give you a positive. It does not matter which direction you read the chart. If you read it across from left to right, or from right to left, or if you read it vertically or diagonally, no matter which way you read it, it's going to give you the correct way to multiply two numbers together with different signs or with the same sign. The next piece we're going to look at is the piece that has DOLOR the robot in there. So this whole thing, all these pieces go together. So this C is to remind us that DOLOR the robot is used for continuous functions. It is used for continuous functions. So for example, if I had a graph that was drawn that looked like this, and I was trying to find the domain and range, then these lines here are designed to help me remember that I need to box in my shape. So I would box in my shape, and that would help me find my domain and range. So remember, DOLOR the robot reminds us that our domain is read from left to right, and our range is read from bottom to top. So DOLOR the robot helps us remember that our domain goes from left to right and our range goes from bottom to top. And we can look at these lines that we have drawn to help us figure out what our domain is going to be. So my domain would go left to right, my range would go bottom to top. This D that's drawn with a bunch of dots is to remind us of a discrete function, because discrete functions are disconnected. Discrete functions are disconnected. And that's what that's why there's all the dots there showing us that it's not going to be a continuous function. And so an example of this, again, you don't have to draw, that would be a function where you had dots. It's kind of like a scatter plot. To find the domain and the range, you would have to find each of the points, each of the x and y values. Our next section is all of these pieces actually go together. So dry mix, if we start with that one, dry mix stands for our dependent variables, which is also our range, and it is our y values for any given function or relation. And the mix stands for our domain, is our independent variable, and it is also our x values for a given function. And then the Dr. XY is just another way of helping us remember that our domain and our range go with x and y. And they go in order. So our D goes with the x and our R goes with the y. The graph over here to the left is a way to remind you that our dependents are our y's because they are drawn on our y-axis. And then our independent variables, or our independent values, are our x's because it is drawn on the x-axis. This entire section here is designed to help you with slope. So you want to write that on your page somewhere. It's designed to help you with slope. We have 4 types of slope. First of all, we have a line that is up and down is undefined. And the clapping hands are designed to help you remember that up and down is undefined. And then the line, so if you have a vertical line, like you see here, this vertical line, its slope is undefined. If we have a slope, a line that's straight across, its slope is 0. Because it can be, a z can be made out of it. If you have a slope that's going up to the right, this slope is positive, which is what the p helps us remember. And then lastly, our slope that's going down is negative, the slope that you can see in the end. This phrase right here, blank per blank, this is our slope. This whole thing represents slope. And our slope is always our y's per our x's. So the way that helps you, if you have a problem, you don't have to write this, but let's suppose you had a problem that said the phrase miles per gallon. What that is telling you is that your miles are your y values and your gallon is your x values, because this word per, remember, is one of our key words for slope. And this last part here where we have this fraction is to help us remember that our slope is our rise over our run. So to find slope, I first have to go up or down, and then I have to go left or right. The next section on our graph is the one that has this formula here. Remember, this is our point slope formula, and this is how we often write our point slope formula. And in the way this is going to work is with y, we're going to put some sort of y value. And with x, we're going to put some sort of x value. And then in front of the parentheses, we're going to put our slope. And it's very important to remember that our y value is going to switch signs, and so is our x value. It is also going to switch signs when we need to use this formula. These 2 happy faces are intended to help us remember our intercepts. So the happy face on the left is intended to help us remember our x-intercept. And whenever we have our x-intercept in an ordered pair, y is always 0. That's why there's a black spot over the right eye, because our y value is going to be 0 for every x-intercept. And it's also important to note that you see these zeros here. That's to help you remember that the x-intercept is the same thing as the 0 of a function. Your x-intercept is the same thing as the 0 of a function. On the right, this happy face is for our y-intercept. So anytime we have a y-intercept in the ordered pair, it is always 0 and then y. So it's always 0 and then y. And also recall that if you're given an equation, for example, you don't have to write this example, if we had 2x plus 4y equals 12, and I needed to find the x-intercept, then to find the x-intercept, I would cover up y. So I could draw a box over y, and then I could solve that, and that would give me the x-intercept. And then to find the y-intercept, I could cover up x, which is what this happy face on the right is showing me. The next section we're going to look at is this one, and this is about our graphing. This is about graphing. Recall that when I have parentheses with a comma, that means there's an x value and a y value. So these arrows are to remind you that when you graph points, you first go left and right, and then you go up and down. And then the graph on the right is to remind you of your quadrants. So our quadrants are quadrants 1, 2, 3, and 4. Our quadrants connect, and if we connect them, they make a C on the graph. That's how we number them, is counterclockwise. This entire section is designed to help you with your inequalities. The whole thing is for your inequalities. And there's a lot of different information in here. Starting with our hands. So remember that our left hand makes a less than symbol, and our right hand makes a greater than. It's easy to remember your left hand makes a less than because they both have that le sound at the beginning. Another way you can remember which one is less and which one is greater is if you look at this, you'll see there is an L, and that one is so this is a less than symbol. And then here I have a G, so this is a greater than symbol. But I also want to talk about why these lines are dashed here. So remember, when I'm graphing inequalities, because these dashes are important, if I'm graphing inequalities, if my symbol is just less than or just greater than, then I have to use a dashed line to graph it. Or if I'm graphing something with dots on the end, if it's just less than or just greater than, then I'm going to be using open circles. The alternative is that I have symbols of less than or equal to, or greater than or equal to. Well, if it's equal to, if you have this symbol underneath it, when you graph it, the line is going to be solid, or you're going to be using dots that are completely filled in. So that's what these dots here on the end mean, is that if it's greater than or equal to, we're going to use the solid dots, versus the less than or greater than, where we're just going to use open circles.